We are working on the Sports Heroes project from the YByte Python curriculum available at www.ybyte.in. We have been doing comparative analysis, which I think is really, really interesting. We saw that 42 people in all, 42 great players in all, have won either Wimbledon or French Open from 1968. 8 have won both. There are 14 who have won only Wimbledon but not French Open, and there are 20 who have won, for example, only French Open but not the Wimbledon, and their names are as listed here. Now, let's ask ourselves another question, which is that who are those players who have won either Wimbledon or French Open but not both? Now, what we have done here, again, very nice to understand from a Venn diagram. Remember, again, set of Wimbledon winners, set of French Open winners. So what we are saying is that, look, you have, we are looking for those people who are in this set or in this set, but they are not in both. Again, what this means is that the intersection players will be removed. And we can do this using this operator, as we'll see in the code now. So I come back to my code over here. I just call it, let's say, winner, say only one. So not only one, that way only one, not both. So I'm just trying to be very, very explicit here that, look, these are the people who have won either the French Open or the Wimbledon, which is one of the two, but they have explicitly not won both, right? So I just go and do winner, say set one, and let's say find a symmetric difference with, let's say, winner, say set two. Now, obviously, I want to report this in my, in the file that I've been creating. So I just go and copy and paste, let's say, this piece of code. Just be careful with the indentation and updating the variables. So let's say only one, say not both. So basically either French Open or let's say Wimbledon, but not both. Now this has to be winner, say only one, not both. And again, winner, let's say only one and not both. Once again, let's run this piece of code. When I do this, my analysis.dat gets updated. So it tells me, look, there are, 42 who have won either or, 8 who have won both, 14 won only Wimbledon, 20 who have won only French Open. And it's, if you really think about it, it's not a big surprise that 34 have won only one, not both. Basically, this plus this, because these are the set of people. So in some sense, we are doing a union of, let's say, this set and this set. And that is also visible from the Venn diagram. One set, this set was those who have won only Wimbledon. This set was the one which has won only French Open. In fact, there is no intersection, there is no overlap between these sets. When I do a union, I am looking at all of these areas which I've shaded. So it's really quite, let's say, intuitive from that point of view. Once again, we can take an example like we have been taking. So if I have A is, say, 1, 2, 3, and I have B, another set which is, say, 3, 4, 5. This is what I've been, say, working with. If I were to do C is, let's say, A, B, that tells me, well, look, that's 1, 2, 4, 5, because remember, in this or that, but not in both. So that's why it's 1, 2, 3 has been taken out, and then I have 4, 5. And as earlier, we can do it in a longer way as well. So I can just go and say A dot, let's say, same, again, be very careful here, symmetric, let me try if this is correct, symmetric difference, let's say B. Oh, so I kind of got it wrong, something, I have made a mistake. Okay, so I know the mistake here. So it's symmetric, and this is really what tells us that one would rather go with a short notation, which is, say, something like this, than typing all this. But the point is, this also works. There's a symmetric difference between these two sets. Now, I prefer to use this short notation, one, because it's compact, but two, also because this operation that we are doing here is in fact quite analogous to what is called a bitwise XOR, as we are going to learn in the bitwise operators later on. And there we use the same symbol for this. So, union is like the OR, symbol is same. Intersection is like the AND, symbol is same. This symmetric difference is an XOR, and again, the symbol is the same. Now, these concepts could be a little bit abstract, but when we apply them to something that we understand, something that we relate to, They come alive for us, and that is what we are trying to do here. That is how we learn Python at YByte. Look at our website for many, many, many such examples. Take care. Thank you so much. Bye bye.